back once again. It is day 95 of daily LeetCode. We've been stuck on this problem called Excel column sheet title. We spent like 3 days on it. Then we looked at the solution at the end or the start of yesterday, I think. And then today would be the 5th day, I think. And I understand what the problem is asking for now. But besides the point, what I'm getting at is, there's not a lot to be gained from this problem. I think I've already gained as much as I can from it. I just need to finish solving it, and then we'll be good. But I think it just goes to show how much the mindset thing goes into it, because this problem isn't that big of a deal, but I'm just stuck on it. Like, I just refuse to move on. And I think it's because the problem is so easy, and I probably staked some bit of my identity in solving it because I knew that it was easy, so I could solve it. But now that I'm stuck on it, it's like I refuse to move on. For some reason, my brain is like refuses to move on unless we solve this. But I already know the solution, I think. We just need to work through it. And I think I'm realizing one of the problems with the 30 minutes a day is I don't really get a chance to go deep into the problem, because it's after like 30 minutes of pondering that I'll start to like really get it. And usually I'm stopping at 30 minutes right there. So maybe we should do an hour a day. Maybe that's the wave. So maybe we'll do an hour today. We'll just do an hour today. And then, I think that would be good. So then we would have time to explore problems fully. So an hour a day, but we'll stay on easies, but we should be able to make much more rapid progress. And I think we should be able to finish this one today. That is besides the point, though. Yesterday's video was called How to Wake Up Early. I've been trying to extract more out of the day waking up early. And it is just harder than one would think to wake up early. So I downloaded this app called Alarm Me, tried to make it work, but I ended up just waking up in the middle of the night and then turning the alarm off. So I think the play is to move it away from the bed, because I said I would try it today, and today didn't work. So but yesterday I deleted the app, and then tonight I didn't delete it. I just ended up turning off the alarm. So what I need to do is charge it away from the bed. So at the minimum, I have to wake up and get out of bed and then move the alarm or turn off the alarm. So then I'd already be up. But yeah, I wish Alarm Me had a lock alarm button so you couldn't turn off the alarm, at least with a code or something, because then it's kind of hard to make sense of it, because then you could just turn off the alarm. But we have legendary comment from Carson E. Same. If I wake up before my alarm, I just power off my phone. Facts. Okay, this is the problem, right? We need the iPhone 16 will solve this for us, I believe. Maybe there's got to be some device you could strap to your chest right above your heart, and if you don't wake up, it just shocks you or something. I don't know, but that would be dope. We have a message from Thomas. Brother, you should do the weekly contest tomorrow. Would be dope to see it. Haha, I will do it with you. Ooh, they got some messages queued up. Not a bad idea. I'm stuck on this problem. I want to do it so bad. Maybe we'll. Either way, after we finish this problem, we'll do the weekly contest. I promise. We'll give it a shot. But we have to do this. I have to get this through this problem, because even after I do the LeetCode throughout the day, it just sticks in my head that I don't understand why I can't solve this problem. I think once I get out of my head, I should be able to solve it. So I'm going to try and go Zen mode, and slow down, and not stake my identity in solving the problem, and then maybe I'll be able to depersonalize the problem and then just work on it. But I think my identity thing is like making this so much more difficult, because the whole time thinking, instead of actually solving the problem, the whole time thinking, why can't I solve this? So I'm just too in my head, and I just need to work at the problem. Plus, we already looked at the solutions. Or I guess we peeked at the solutions, so I shouldn't take too long. As soon as we finish this, we'll do the weekly contest. I don't know which one Thomas is mentioning. Maybe it's 310 or 312, but we'll check to be sure, and I'll say challenge accepted right after this doggone problem. Sad face. So we're going to jump into it. We're going to do an hour today. And then I think we're just going to start doing an hour for this in general. And then I think that should help just in general with focus. So yeah, ideally I will report back tomorrow to see if the moving the phone away from the bed with Alarm Me works. But yeah, we'll have to see. Other than that, I'm thinking I'll buy one of those boxes where you lock your phone up and it like literally doesn't open. And then I'll just put my phone in there. So then I have to do it. But yeah, so that's going to be today. So we're going to try and do an hour today. A bunch of easies. So let's just jump into it. So I'm going to start the timer. Let me do a recap. We thought it had to do with base 26. It's safe to say at this point it does not. So we did the base 26 thing, and then we spent 3 days trying to figure out why it wasn't working. And it has nothing to do with base 26. I think it just happens to do with how many times 26 goes into the number, the current number. So then we wrote an algorithm that pretty much just checks how many times 26 goes into the number, but we ran out of time. That algorithm looked like column number divided by 26. So I'm going to restart, and the way we're going to do this, I'm going to scaffold it this time so we don't get lost in thought loops. I'm going to rewrite it for correctness first till we get TLE. Once we get TLE, we'll optimize it. That way we just slow down. We want to return title. So I think the way the problem works is given column number, number of times 26 goes into the number. And let's double check this first, right? So now we have the numbers that we're looking at. We're given a number like 1 and we want to return a letter. So we have 1. How many times does 1? How many times does 26 go into 1? 0 times. So we did 1 divided by 26, we get a number less than 1. If we get a number less than 1, less than or equal to 26, then we know that that's the last number for certain. So I think that's what we had last time. But if we get a number greater than 1, then we know what? What do we know? So if we have 27, how many times is 26 going to 27? We'll know that column number should get the value of column number mod 26. Because if we had 27, column number mod 26 would actually give us 2. Would actually get 27. If we had 27, column number mod 26 would actually give us a remainder of 1. Right? So the first thing we have to know to branch this code is how many times basically 26 goes into column number. We'll call this dividend. We'll call it column number divided by 26 dot floor. we have two cases, right? If dividend equals 0, right, then we're going to want to have a different branching logic here, where if dividend equals 0, it's going to mean that 26 doesn't go into the number at all, or not so much that we get at least one whole number from it. So an example of that would be 1 divided by 26. We'll get something like 0.5 or something like that, which would mean that column number, or the number, or the character that we should add to the title should then actually be title plus equal column number mod 26 plus 64.car, right? So to make this make sense, if we had column number, which is 27, right, mod 26 would give us a remainder of 1 plus 64 plus 64 would give us A. I think ASCII value A starts at 64. Afterwards, right, we would know that column number is empty because, right, if we divide a number by 26 and we get something that's not at least 1, then we know that the value is less than 26, which means column number is not, and this is the final operation for column number, basically. So you can just set column number equal to 0, and now we'll have else right. So now we're going to have a different branch here. Right, and I think we don't need all this code here, but we'll say in this case, right, how do we get the value for, let's just say we had 27, right? Dividend 27 divided by 26 dot floor would give us like 1. So we're going to go into this else because dividend doesn't equal 0. Now column number, right, the new value of column number should be column number mod, nope. We'd like to subtract a value from column number. And I think that value would actually be 26 times dividend. So if we had 52, right, dividend would equal 2. And we'd say column number minus equal 26 times dividend, which is 2, which would be 52 minus 52, which would be 0. Then we don't need this part. I do think we have something slightly to worry about. If we had something like 701, right? 701 divided by 26, or 702 divided by 26 gives you 27. Right? And presumably the number that the letter that we would add to the title would be the dividend, right? Dividend plus 64. So we would so this might be too simple. Minus equal 26 times dividend. Might be too simple. column number minus equal 26 times dividend. Because we could, if we divide it by 26 and we get something like 27, that's too big because the letters that we can use are A to Z, which is 26 letters. So that would be a problem. So we'd have to bound it. So we could say bounded. What if we bounded the dividend so that if it's greater than 26, right, we just bound it to 26, right? So if we did 702 divided by 26, we get 27. The bounded dividend would, I guess, would clamp it to between 1 and 26. And then we would do 26 times 26, right? Subtract from column number, which would give column number a remainder of 26, which means we would get Z and then Y. To do that, you could say dividend is greater than 26, right? It gets the value of 26, otherwise it gets the value of dividend. Do we need this title dot reverse? We're given 28, right? 28 divided by 26 is 1 point something. This doesn't equal 0, so we do else, right? 1 is not greater than 26, so we get the value of dividend. So we column number minus equal 26 times 1, which would give us 2 for 20, or 1 for column number. So we're doing AA. So title plus equal, actually we'll do 28 instead. We'll say title plus equal A, and then there'll be 2 left, so we should need to reverse it. So let's try this. Looks like we're missing an end. Oh, are we still using? We're supposed to swap these dividend values for bounded dividend. So now we get TLE. This pretty much bounds us at only being able to divide up to 26 numbers. I mean, up to 26 basically. So we have a massive number like this. If we do divide by 26, what happens? Right, we get a massive number. And so it takes us a long time to build the string. Because basically we get a number that is 82.5 million. And that's going to take a long time because we're going to, on this bounded dividend line, we're going to say 8.5 million is greater than 26. So we're going to give it the value of 26. So we're going to add a Z. So the way we could go about working this down, I think, is what we decided, right? So this version gets TLE, And I'm not even convinced that the problem is asking for number of times 26 goes into the number, because at the end, right, 26 doesn't go into 2, right? So we end up putting b there. So I just don't understand what the problem's asking for. But we did get it to TLE, then we said we're going to optimize it. Now, what if dividend is greater than 26? We handled that by bounding it. Handled that by bounding it. Now we need to do modulus. Modulus would potentially be faster, but you end up building the string in reverse. It looks like the test cases that we should worry about are 26, 28, and then 701, and then 702. So what if we did this with modulus? If we did 26 mod 26, we get a remainder of 0. Now the goal answer for 26 is actually z. This for 28 is actually a, b, 701 is actually zy. No. Let me see what that is actually. Oh, so it is zy. Let me check 702. That output is wait, we got TLE and I assume that the code worked. Oh wait, no, yeah, now I'm realizing the code doesn't work. So we're given 702. We're given 702. The expected answer is ZZ. Yeah, so our model of the problem is just not correct. So 702, the go answer is ZZ? We know this isn't base 26 because 702 in base 26 is just A0. Or AY. How is 701 ZY? 701 maps to ZY. How is that possible? Seven hundred and one is ZY. 702 is ZZ. 701 is ZY. Seven hundred and one in base 26 would be AY. This doesn't make any sense. How is 701 ZY? With our previous style, we did divided by 26, and we get 26. We bounded our potential interests at 26, but we don't even get the right answer. Our previous version with base 26 actually got us the right answer. Or well, not. I think it could. This version isn't even correct. So if we did, let's just follow it through then. We did column number does not equal 0, it equals 702. Column number divided by 26 gives you 27. 27 does not equal 0. 27 is over 26, so we bound it to 26. We say column number minus equal 26 times bounded dividend, which is 26. 26 times 26 is 676. 26 remains. Title plus equals 26 plus 64, which gives us Z, which is perfect. Then we go up top with 26 remaining, where 26 divided by 26 is 1, which isn't 0. Say dividend is greater than or equal to 26. Dividend isn't greater than 26 is equal to 1. So then we say column number minus equal to 26 times bounded dividend. I'm seeing why we get A now, because when we get bounded dividend, it equals 1, so we end up adding A. But if it goes into it, 26 goes into the number 1 time, then it should actually be Z we place, because the whole number goes into it. Okay. Well, then if the number goes into 26 goes into the number 27 times, then we should put it's not base 26. It's not 26 going into the number, or that simple. ZA. think we have to look at the solution. This doesn't make sense. This person is doing, okay, find, this looks like a recursive, is this the recursive version? No. So they say divide equals 0. They floor column number mod 26 is not equal 0. So let's say column number equals 28. Column number, which is 28 mod 26, column number which does not equal 28, column number which equals 28 mod 26 gives us a remainder of 2, which does not equal 0. Result plus equal math.floor of column number mod 26, right, which is 2 plus 64, which would give us B. Results plus equal B. If divide is greater than 26, will divide equals 0. Oh, this is recursive because they have spawn column here. Let's look at a non-recursive version. This person has a string builder while n is greater than 0. The remainder, so let's do 28. We'll do 28 minus 1 gives us 27 mod 26 gives us 1. SB.append a plus rem, which would give us B. Well, let's see, what's the goal answer for 28? The goal answer is AB. Goal answer is AB for 28. So if you do 28 minus 1 gives us 27. 27 mod 26 gives us 1. Remainder. We're going to do A plus remainder, which is B. Then we're going to do N, which is 28. 28 minus 1 gives us 27. 27 mod 20 divided by 26 gives you 1. BA, and then they reverse it. But I don't understand how subtracting it by 1, I don't understand why subtracting it by 1 even works. We take A at 0 index and Z at 25. So after finding the module 26, we can reach at the position after adding 1 divided by A. So we have 28, right, column number which is greater than 0. We're going to say N is equal to column number minus 1, which is 27 mod 26 gives us 1. We say A plus 1, which gives us B. And then we say S is equal to C, which is B plus S. And then say column number divided by 26. 28 divided by 26 gives us 2. This one can be done easily by processing each digit in the 26 based system. We take number, take every small digit by doing modulo, and then prepare number for the next iteration by doing division. In order to look up the car, we prepare array of characters. So 28 is greater than or equal to 0. Res equals letters sub 28 mod 26, which gives you 2 plus res. So if we get 2, what's this tooth index? 0, 1, 2 would be C. The number system here is a base 26 system because it has 26 letters. Only difference is instead of 0 to 25, we have 1 to 26. So whenever at a particular digit the sum is divisible by 26, we put Z, i.e. 26, not 0. If we put 26, we cannot carry the whole sum to a higher digit. Let's take a number system having 1 to 9. 1 to 9, A. 1 to 9 and then A as 10. And count 1, 2, 3, 4, 5, 6, 7, 8, 9, A. 1, 2, 1, 3, 19, 1, A. 2A. See, the only difference with the normal system is when the number is divisible by the base value, which is 10. Instead of putting 0, we have to put A and carry sum minus base divided by base to next digit. E.g. 110. First digit, 110 is divisible by 10, so we have to put A. So remaining sum becomes 100. Because sum, which is 100 minus base divided by this makes a bit more sense. And this, that means it's crazy because, man, this is crazy because it means our original solution of implementing base 26 was correct, because as we tested, it worked for every single number except when the number was the number was perfectly divisible by the base. So when we had 26, we got the wrong answer. When we had 702, we got the wrong answer. But for every other number, it was correct. Oh, man. See, the only difference with the normal system 0, we have to put A and carry some minus B's. I think this version makes more sense. You know what? I don't think we should. We just read the solution on this. And I'd like to mark this problem as a problem we come back to. So I'll add it to a list. I think you can add problems to a list somehow. Because I want to come back to this problem, but I don't want to, if we solve it with what we just read, I think there'd be no point. So what I want to come back to it though, because I'm sure we'll be back to this problem. So I did promise we try the weekly. So let me see if I can set that up real quick. In 4 hours. So this contest is in 4 hours. Oh, so it's in 4 hours, so we can't do it now? Right. So I guess we'll have to try it tomorrow then. So I guess we'll try and go to the next one since this is in 4 hours. So back to problems. So we have like 12 minutes left, so let's just see what we can remain to solve. Given the head of a linked list and an integer val, remove all the nodes of the linked list that has node.value equals val and return the new head. So we're given the head of a linked list, right? And we're given a value which is 6. We're going to remove all the nodes that have a value of 6. Okay, that makes sense. Looks like our linked list can also be empty, right? And in the case where our whole entire linked list is these values, then we should have nothing remaining. So we'll just do that. Now we'll just say return nil. We'll just return head if head equals nil. Right, and then I think for the approach for this one, the approach that we could take is a lot similar to move zeros, where we'll have a 2-pointer approach. We could have one start here, right, and the next one be here. say, right, if next, which is 2 equals value, right, which is 6, right, then we'll wrap it around, but it doesn't. So we'll just move this one up and move this one up. Now we'll say if next dot value equals 6, which it does, right, then we'll say cur, which is 2, is equal to cur dot next. So we'll wrap it around here, and then we'll stay here at 2, right, because we could have another value, right? 6 could be, the next value here could be 6 instead of 3, right? So now it'll look more like this, 2 arrow 3, right? And we'll say 2 does not equal, or if cur does not equal. So now I'm seeing we actually don't need that next pointer. So let's just say if cur make sure we test these cases. So let's just say for the simple case, the numbers that we need to replace are in the middle. We'll say cur dot val, right, equals 6, right, but it doesn't, so we'll go to the next one. Cur dot val equals 6, it doesn't. So we know, right, that we can't be at the node itself, we need to be before it. So we'll say we'll restart with a new idea. We'll say we'll start at cur, if cur dot next dot val equals 6, right? If it does, then we'll do some work, but if it doesn't, we'll move forward. So in this case, we'll move forward. We'll say if cur dot next dot val equals 6, then we want to wrap around it. So we'll say cur dot next equals cur dot next. So cur dot next will now be equal to 3, and we won't move the pointer at all. So now we're going to say if cur dot next dot val, which is 3, equals 6, then we want to do some work. It doesn't, so we'll do cur equals cur dot next. Now we're going to be at 3. The next one isn't 6. The next one isn't 6. Now we're going to be at 5. We're going to say cur dot next, right, dot val equals 6. It does, so we'll say cur dot next is equal to cur dot next, which is null, which is perfect. So I think in the middle and at end works. Now what if cur is at the front? If 6 is at the front, or if it's at the front, then what we'll do is we'll just we'll move forward until the value isn't null. So let's just say we have an entire value of 6s, an entire head of 6s. We'll say head is equal to cur dot next, head is equal to cur dot next, head is equal to cur dot next, right? If cur dot val equals val, then cur equals cur dot next, right? And then we should get all the way to the end, and it should be nil, right? Otherwise, we should be able to stop at the one right, the one that is not the same as the value. So that was like a 5-minute scaffolding. So I think we have two things: move head forward until head.val does not equal val, and then what we're going to want to do is then iterate through rest of LL if cur.next. We'll say if cur and cur.next or that I guess that'll be for the while loop, so we'll just keep that for the while. Basically, we want to iterate through the rest of the linked list. We're getting too deep into the logic here. Iterate through the rest of the linked list if next node val equal val, remove it, else move forward. So we'll say move head forward, and so head.val does not equal val. So we'll say temp equals head, right? And we'll say while temp, right? And temp.val equals val. We say temp equals temp, or I guess we can just use head actually. Head equals head dot next. So if we use the example test cases and just use one with all duplicates, we should be good, because if we return head, or we can just say head. So we're good for that case, and then now we want to iterate through the rest of the linked list. To do that, I think we're going to want to use that temp variable. We can say while temp exists. If we're saying while temp exists, we want to be able to check the next value of the node, because we're going to be routing around it. So we do want to know that that value exists. So we can say temp.next. But this messes, oh no, yeah, this is okay. Yeah, this is okay. I was going to say if we had just a linked list with two values in it, 1 and 6, this wouldn't work, but it would. And we'll say if temp.next.val equals val, we want to remove it by routing around it. How do we do that? We'll say temp.next equals temp.next. So temp.next, which is this arrow, equals temp.next.next, or we're replacing the 6. Temp.next, which is this arrow, equals temp.next.next, wraps onto this 3, and we don't want to move it forward. Now, if the values aren't the same, now if temp.next.val does not equal 6, then we want to move forward. So temp equals temp. So if we try this for a simple case like this with 1, 2, 3, 1, 2, 6, pretty much this one right here. Okay, head and head.val equals val. Well, this one doesn't equal 6, so we're just going to go in here, right? 1 and 2 both exist. Does temp.next.val equals 6? No. So we move to temp equals temp.next. Does temp and temp exist? Yes. Does temp.next.val equals 6? Yes. So temp.next equals temp.next.next. Right? So now we have 2, arrow 3, and we're still going to be at 2, so we're going to say, does 2 and 3 exist? Yes. We do temp equals next. Now temp is going to be 3, right? Does temp.next equals 6? No. So now we're going to be 4. Does temp.next equals 6? No. Now we're going to be 5. Now we have temp and temp.next both exist. Does temp.next.val equals 6? Yes. Temp.next equals temp.next.next, which is nil. Is in temp. And then while temp and temp.next would be false, because next will be nil. So this works. I think this should work in linear time with constant space, because we're not really saving any values. We're just using one variable. So I think we should be good. We have like 1 minute left. We have like 1 minute left, and the video is already long, so I'm just gonna stop here for today.